This video is over lessons 78 and 79, lesson 78 capacity, and lesson 79 area of a triangle. Take a moment to copy these titles into your notes. When you're ready, press play. Moving on in 3, 2, 1. Capacity is a measurement of how much fluid or how much liquid something contains. And so therefore it is related to volume. And when measuring capacity, we have two different systems that are typically used. And so in your notes, I'd like you to make a chart with two columns. Here in the United States, we generally use the U.S. customary system. Whereas much of the rest of the world uses the metric system. In the U.S. customary system, the largest unit that we typically use is the gallon. Little smaller than that is the quart, and I'd like you to skip a space as you write that. We're going to go back and fill it in a second. And then skip another space. Underneath the quart is the pint, and a little bit smaller than a pint we have a cup, and a little bit smaller than cups we have ounces. Now technically we can go smaller into tablespoons and teaspoons, but we're not going to today. So in those spaces we skipped, with a red pen, we're going to fill in the conversions. So a gallon, abbreviated GAL, is equal to 4 quarts, abbreviated QT. So notice the word quart kind of reminds you of quarter. Well, 4 quarters in a dollar, 4 quarts in a gallon. And let's continue. 1 quart, so QT, is actually worth 2 pints, PT. 1 pint, PT, is worth 2 cups, which can be abbreviated as just C. And then finally, 1 cup is worth 8 ounces. On the metric side, there are many different units for measuring capacity in the metric system. However, many of them don't get used. In the end, it really ends up being the liter and the milliliter that get used. And the conversion between these two is pretty simple. The metric system is all based on tens. So we have a liter, slightly smaller than that, which we haven't listed, is a deciliter, which 10 deciliters make a liter. And then slightly smaller than a deciliter is a centiliter, which it takes 10 centiliters to make a deciliter, and then it makes 100 to make a liter, and then underneath that is the milliliter, which it takes 10 milliliters to make a centiliter, therefore it takes 100 milliliters to make a deciliter, which means it takes 1,000, so milli means 1,000, to make a liter. And so the conversion is 1 liter, which liter is abbreviated with a capital L. So 1 liter equals 1,000 milli, small l or small m, excuse me, and capital L for liter. One last note, going between the two systems, and I'm going to do this in blue, the best way to link these up is to go from the quart to the liter. They are pretty close in size, but they're just a little bit off, with the liter being slightly larger. So 1 liter equals 1.056 quarts. Moving on in 3, 2, 1. Now we're going to do a quick review of how to convert when using capacity. So let's say I have 1.5 gallons and I want to know how many pints that is. So first step is going to be to take this amount and turn it into a fraction. Now I could take 1.5 and turn it into 1 5/10 and then reduce that to 1 1/2, change that into a improper fraction, or I can just keep things really simple and just make it 1.5 over 1. Now the gallons are going to tag along, so it really ends up being 1.5 gallons over 1. And then we're going to multiply by a unit multiplier. So here we need to remember what we know about gallons. Well, we learned that 1 gallon equals 4 quarts. So I'm going to use that as my first unit multiplier. So since gallons are on top, in order for these to cancel out and disappear, I'm going to need gallons on bottom. Well, gallons, the number that goes with it is 1. Up top, I just put in the other measurement, so 4 quarts. Now I have gallons on top and I have gallons on bottom, so they're gone. If we look at the units that are left over, since these are both gone, all that's left is quarts. So if we multiplied right now, our units would be in quarts. Well, that's not what I want. So let's multiply again. So now I need to remember what we've learned about quarts. Well, we learned that 1 quart is equal to 2 pints. So that will be my next unit multiplier. Since I have quarts up top, I'm going to need quarts on bottom in order for them to cancel. And it was 1 quart that is equal to 2 pints. Now I got quarts on top and quarts on bottom. And so if I multiply these 3 fractions right now, there are no units here, no units here, but pints here. So my answer will be in pints, which is exactly what I'm looking for. So multiply my 3 fractions together. Well, 1.5 is kind of like a 15 with 1 decimal place in it. So for the purposes of multiplying, remember we multiply like whole numbers. So I've got 1.5, which I'm going to multiply like a 15, times 4. Because of the clock, we should know that 15 times 4 is 60. Now I've got 1 decimal place here. I have no decimal places there. So that's going to be a 60, but then I've got to move the decimal so that there's 1 decimal place, which will make this 6.0, or just 6. Then we got to multiply by 2, and so the answer comes out as 12. Now we've got to multiply the units. No units times pints means it's just pints. On bottom we do the same. So 1 times 1 times 1 is 1. No units means no units. So 12 pints divided by 1. 12 divided by 1 is 12. Pints divided by nothing is pints. So 1.5 gallons is 12 pints. This video will move on in 3, 2, 1. Before we move on to the area of a triangle, first we need to stop and review the area of a parallelogram. So remember, a parallelogram is made up of 4 sides where every side that's opposite of another side is parallel. And so the area of a parallelogram is A equals BH, where B stands for base And h stands for height. But we also need to remember that the height is formed by making a right angle with the base. And so this becomes super important. Must make a right angle. Now that we have that in mind, we're ready to move on to triangles. The reality is, every parallelogram is actually made up of two identical triangles. For that matter, if you take two identical triangles, you can always put them together to make a parallelogram. You may be able to make other things as well, but you'll always be able to make a parallelogram. Moving on in 3, 2, 1. So as we look at the area of a triangle, we need to keep in mind that two identical triangles can always make a parallelogram. So in a way, a triangle is half of a parallelogram, which leads us directly to the formula for the area of a triangle. So if a parallelogram's area is base times height, a triangle will be half base times height. So now we're going to take a look at some examples. So let's make a triangle that looks something like this. And I'm going to tell you that this side is 11 inches, and I'm going to tell you that this side over here on the right is 6 inches, and I'm going to tell you that this measurement here, which is not one of the sides of the triangle, is 4 inches. Now I need to plug in the appropriate numbers into the formula. So we know that A equals 1/2 BH. Well, I'm trying to find the area, so that means I don't know what A is, so we'll leave it just A, equals, the very next thing in the formula is half. So leave it half. Now a number right next to a letter implies multiplication, so I'm going to use multiplication dot next. And then I need to multiply by the base. So the question is, which one of these is the base? I know that the base is either going to be 11 inches or 6 inches, since the base has to be one of the sides. But which one? Or for that matter, it could even be this missing side. Well, we're looking for the right angle. And there's my right angle symbol. And so the right angle is being made with the 11. So therefore, 11 inches is the base times the height. So what is making the right angle with that 11-inch side? Well, it's not the 6 inches, but it is the 4 inches. So the 4 inches and the 11 inches are my base and height. So times 4 inches, and now we're ready to multiply. So since this is all multiplication, the order doesn't actually matter. So I could take half of 11 and then take the answer and multiply by 4. I could take half of 4 and then take that answer and multiply it by 11. Or I could do 11 times 4 and then take half of its answer. What's probably easiest here is to take half of 4, since we know that that's 2. Then times it by 11, and so we find out that the area is 22. Or at least that's the number for the area. Now we've got to do the units. So no units times inches means that this is square inches. So 22 square inches is my area. Moving on in 3, 2, 1. For our next example, let's do a triangle that looks kind of like this. And we're going to call this side 5 inches, and we're going to call this side 12 inches. So this time, I'm trying to figure out A equals 1/2 times my base and my height, but we're looking for the right angle. So what two things are making the right angle? Well, this time it's two sides that are making the right angle, which means that the height in this triangle is actually one of the sides. And it really doesn't matter which you choose. I could say that 12 inches is the base, and if that's the base, then 5 inches is the height. I could say that 5 inches is the base, which would make 12 inches the height. It really doesn't matter which one's which, but the base has to be one of the sides, and the height has to make a right angle with it. So I'm going to go ahead and take 12 as my base. So 12 inches, and that means that 5 inches is my height, and now we're ready to multiply. Again, it doesn't matter what order you do things in so long as you use all three numbers. So I'm going to start by taking half of an even number if I can. So half of 12 is 6, and then times 6 by 5, and I get 30. No units times inches, again gives me square inches. So the area of this triangle is 30 square inches. Moving on in 3, 2, 1. For our last example, let's take a look at a triangle that looks something like this. So this time we've got this really big slant over here. So none of these sides are making a right angle, and especially if I would like that to be my base, which it doesn't have to be, but if I'd like it to be my base, that means that I have to come from up top and make a right angle. Well, there's no way to do that inside the figure, but that's no problem. What we can do here is extend this side and then drop this down so that the extended side and the height make a right angle. So let's say that this guy over here is 7 centimeters, and we'll say that this is 6 centimeters. So the extended side and the height are the two that make my right angle. So plug those into the formula. A equals 1/2 times the base, which is always one of the sides. Here, that's 7 centimeters, times the height, which always makes a right angle with the base, or the extended base, which in this case is 6 centimeters, and we're ready to multiply. I would take half of an even number if I can, so half of 6 is 3, times 7 gives me 21. No units times centimeters gives me square centimeters. So 21 square centimeters. This video ends in 3, 2, 1.